We're now going to begin talking about fractals. The first fractal that we're going to look about is the Koch snowflake. Now in this code we're going to be using turtle, which is a different form than tk-enter. What turtle is essentially you can tell the turtle to go forward and it'll draw everywhere it goes. You can tell it to turn left and right and it'll basically turn in that direction so that the next time you tell it to go forward it'll draw in a different direction line. Now a fractal is essentially a recursively defined drawing. They're actually really cool. So the Koch's snowflake specifically is like this. So the level 1 Koch snowflake is just a triangle. Then if we make it level 2, it looks like this. Each side looks like this. Then we go here. And now if I make it level 3, basically I'm just going to look at one side. So originally a level 1 was just like this. Now a level 3 is going to be essentially, I'm going to draw this entire thing, but on each individual line. So let's see what this looks like. The first line will have this. Now the second line I draw will also have it. The third line. And then finally this last line also has the entire drawing there. So we can see that to go from here to here, I essentially redraw the drawing, but on each individual line. So this is why it's called a fractal, because if I look at this, there are actually 4 different Koch snowflakes in here, but they're all just a lot smaller, and they comprise of a bigger one. So what we want to do is essentially draw a Koch snowflake in this way, and be able to do it recursively. Because if you think about it, to draw this one, I just have to recursively draw a bunch of smaller ones within. So if we look at the code, specifically this key excerpt, if I want to draw a Koch snowflake of level n, well, what I do is I essentially say, okay, first of all, draw a Koch snowflake that's 1/3 the size, but then n minus 1. That's essentially saying, okay, draw an entire Koch snowflake in here. Then, after that's drawn, turn left 60 degrees. So imagine that the turtle basically was going in this direction, and it drew a Koch snowflake over here. Now I want it to turn left, so that it's now going in this direction. And now it's going to be drawing a Koch snowflake over there. So it'll go up and draw a Koch snowflake. So it draws it. Then I say, okay, turn right 120 degrees. So now it was going in this direction. It'll now turn right and go down in this direction. Then I say, in the right direction, draw a Koch snowflake of n minus 1. So now it'll draw that. And then finally, I say, okay, turn left again. So now it'll be going straight. And I say, draw a Koch snowflake of n minus 1. So it'll draw it here. So, in the end, we can see this is how we're going to be recursively drawing the Koch snowflake. A fractal is always going to essentially be defined this way. We say, okay, let's draw the fractal, but in order to draw this one, we have to call ourselves recursively and draw a bunch of different smaller ones. Now notice that in recursion, remember, we always want to make the problem smaller. So we're first of all drawing a smaller length Koch snowflake of length 3, or length divided by 3, and we're also saying, okay, reduce the depth by 1. Now in the base case, when n is equal to 1, we just move forward, because if you remember, this was a Koch snowflake of size 1, but an individual side is just going to be the single line. So we go from there, then it's n minus, if it's n equals 2, and then finally if it's n equals 3, and I can't draw this, but this would be a Koch snowflake of n equals 3. So, thus, we stop when our n is equal to 1. This is how you're going to generally be doing fractal problems. You keep recalling yourself recursively and drawing yourself with a smaller n and with smaller sides.